All right, good morning, everyone. Welcome to Breakfast by the Bay. My name is Adam Kowarski. I'm Save the Bay's aquarium biologist or aquarist, and we're here today to learn about some really fun things. We're going to be learning about one of people's favorite animals, the northern lined seahorse. That's right, seahorse. A lot of people don't realize we have seahorses in Narragansett Bay, but we actually do. They're one of my most favorite animals. They're beautiful and amazing. Why don't we take a quick look at them right here? So you can see we got a couple hanging out. They're getting ready for their breakfast as well. So things we're going to be doing today are feeding these guys at the end of our segment here. And we're also going to be doing a little science experiment. And you might wonder, what do seahorses have to do with a science experiment? But by the end, hopefully you'll get the idea. Now let's take a look over here. So we have the beginning of our science experiment right over here. And what we're going to do is actually start it right now, and then by the end of our little section here, we're going to come back and look at it. So once again, for anyone joining us right now, my name is Adam Kowarski. We're here with Save the Bay doing Breakfast by the Bay. So the first thing I want to take a look at here is we have this little flask right here. All right, and it's got some pretty cold water in it. And I'm taking a look. It's about 4 degrees Celsius. And we're in our little flask here. We got a thermometer, a little tin foil to help insulate it. And if you take a look, we got a little black line right here that's indicating the water level of the water in our flask here. So the first thing we're gonna do is we're gonna take our flask, we're gonna stick it right over here, and we're gonna turn on these heat lamps. We're gonna start heating it up, all right? So the idea is we're going to be learning a little bit about something called sea level rise and thermal expansion, and hopefully by the end of our little segment here, we're going to see a change in the level of the water there to teach us a little bit about how sea level rise works. And hopefully I'll be able to tell you guys how that relates to seahorses. All right, excellent. Why don't we take a look back at our seahorses here, and we're going to learn a little bit more about them. So taking a look at a seahorse, one of the first things I noticed about them, these guys aren't great swimmers. Look at them, they're pretty awkward, and you know what? How do these things survive? Well, you know what? They have some really wonderful adaptations. You can see at the end of their body, they have this prehensile tail. They used to hang on to things. Where they live, there's a lot of wave action and wind that blows the water around as well, and they need to hang on to things like eelgrass. So you can see there's one in the back there kind of hanging on to the eelgrass, and just making sure that it's nice and safe. And we can talk a little bit more about that. Next thing I want to do, let's classify these guys. Let's take a look at this sign over here. All right, so the northern line seahorse, it's part of, the vast amount of organisms that are on our planet, and we're just going to ID these guys here and just do a little bit of taxonomy. So these guys are in the kingdom Animalia. So that means they eat other organisms, they reproduce embryonically, all right? They're not a plant, they're not getting their energy primarily from the sun, so that's how they're different from a plant. Their phylum is chordata. That means that they have a spinal cord. We have a spinal cord as well, and we've done this before, but if you don't remember, you can take a couple fingers and feel that bump on the back of your neck right there. That's your backbone, and within your backbone and your spinal column, that's where your spinal cord is. And you know what? A seahorse has that as well. One way that they're a little bit like us. How interesting. All right, their class is called Actinopterigi. Sorry, my Latin's a little bit off right now. And I actually had to look up what that meant before this little class here. So that means that they are ray-finned fishes. All right, and for those of you that don't know what that means, if you've ever looked at a fish and looked at their fin, they have all these little bones moving through their fin. They call those rays. So some fish have those rays, some don't. A good example of a fish that does not have those rays would be like a shark or a skate or a stingray, something like that. They are not a ray-finned fish. All right, excellent. So the order for them is called Sygnathiformes. All right, so that includes things like sea dragons, seahorses, pipefish, and then even a number of other species are within that classification as well. And then it zooms in a little bit further. We go to their family. That's called Sygnathidae. So that family includes sea dragons, seahorses, and pipefish exclusively. All right. And then the next one is their genus. We're getting almost to exactly where we are with the seahorses here. So their genus is called Hippocampus. And if you actually translate that from Latin, that means horse or sea monster, right? When you look at these guys, they look kind of like a horse, they look kind of like a monster. What are these things? So maybe that's what they were thinking when they classified these guys. And their species is erectus. That just means upright. So these guys are an upright sea monster. That's what people thought when they were classifying these guys, which I think is just such a cool thing. All right, excellent. So like I was saying before, these guys live primarily in eelgrass. So eelgrass is the only flowering plant that lives in Narragansett Bay. So that means it has roots, it gives off flowers and gives off seeds and reproduces that way. So any plant needs a few different things to survive. One thing it needs is sunlight. So anywhere you're going to find eelgrass is only going to be in shallow areas just below the low tide line where enough sunlight can penetrate the water and actually get down there so they can grow. So these guys love to live in those eelgrass beds. It creates nursery habitat where lots of young life live, like scallops, other juvenile fish, the seahorses, pipefish, things like that as well. And it actually helps to filter toxins out of the environment and do lots of really important things for Narragansett Bay. Now these guys, since they only live in those eelgrass beds, they're actually in a little bit of trouble here. Eelgrass beds are actually a disappearing habitat worldwide, and we're going to talk a little bit about why that's happening. And to do that, we have to talk a little bit about climate change. And one thing that's happening is sea level rise is making it hard for these guys, for the eelgrass to actually grow. So as a quick review, because I know we talked a little bit about this yesterday for anyone who was there, but some of you might be new. So climate change, basically the way this works is when we burn fossil fuels like oil, coal, and gas, it releases carbon dioxide into the atmosphere. That carbon dioxide goes around our planet and kind of acts like a heat-trapping blanket, which then warms up the atmosphere and the oceans in turn. All right. So since about 1930, the average temperature of Narragansett Bay has actually increased about 2 degrees Celsius on average, and the sea level has actually risen around 7 inches as well. All right. Now, the reason why that could be such an issue for these guys, that increased sea level is making it harder for the sunlight to penetrate where the eelgrass lives, and they're not able to photosynthesize and grow. So the size of those eelgrass beds is reducing, along with some other factors, but that's one of the biggest ones. So why don't we take a look at this poster over here. So this one here just kind of demonstrates that idea. So if we take a look, so let's imagine that in 1840, this was the level of the sea in Narragansett Bay. This is the level of the bay. We got the bottom of the bay, we got a nice eelgrass bed and the sun here. So at that point, the sun was able to penetrate nice and deep. The eelgrass bed is able to grow. Let's fast forward about 90 years to 1930, just around when a lot of the Industrial Revolution began and we started burning a lot more fossil fuels. And you can see at that point, there wasn't a lot of effect from sea level rise that was non-natural. But since our oceans, our sea levels have been rising naturally for a really long time, you can see it's risen a little bit in 1930, but that rise was slow enough that the eelgrass was able to slowly migrate to a depth that's closer to the shore, a little bit more shallow, the sunlight can still penetrate. These grasses have evolved and adapted to be able to do this over millions of years. Then you can see after 1930, when we started burning more fossil fuels, increasing the temperature of the ocean, you can see we got a much more drastic rise in sea level, all right? What this means is the eelgrass wasn't able to really migrate as quickly, so there's less of it, and it's a little bit deeper. You can see the sunlight can't quite penetrate as deeply there. So that's less habitat for our beautiful little seahorses, and is what's causing some of these issues here. But I'm here to tell you today, you know what, we can fix this stuff. There's a lot we can do to help reduce the effects of climate change and help eelgrass and seahorses as well. So don't get down, we got this. All right, so the next thing I want to talk about is what's causing sea level rise, all right? So there's a few different things. A lot of people know about the melting of our ice caps. So as our atmosphere is getting warmer, the ice caps on the North and South Pole are starting to melt and push water and shed water into the oceans, was making it rise a little bit. Now, a lot of people think that's the main cause, but the actual thing that's making the water rise the most on our planet is something called thermal expansion. Water has this weird property where when it heats up, it actually expands and then moves higher up on the shoreline here. So I have a little graph over here. Let's take a look at that and see if I can try and describe this a little bit more. All right, so you can see on my graph here for thermal expansion, we have our volume over here on this axis, and then over here we have our temperature on this axis here. So you can see anything 0 degrees Celsius and lower is going to be ice, all right? And ice actually expands, right? But it's also much less dense, and it'll actually float on top of the water, right? So that's not really causing the issues here. Now, most liquids, when you heat them, they actually expand. Water's really unique. It's really weird. And I'm going to try and show you here. So what actually happens between 0 and 4 degrees Celsius is water actually reduces and contracts in volume, all right? So that's kind of funky, okay? And then from 4 to 8 or even 8 to 12, you can see it actually starts to increase in volume. So what'll keep happening as our oceans get warmer, that volume keeps increasing, all right? Okay, so I love to tell you about all this stuff, but I really love to prove to you that thermal expansion is a real thing that happens on our planet. And hopefully we can take the assumption that it's happening in our oceans. So why don't we take a look again at our experiment over here. If we could take a look at it right here, let's see, what do we think? Now I know it might be kind of hard to see in that red light, but what I'm gonna do while it's sitting there, I'm gonna mark where the water level is, and then we'll go check it out on the board. All right, I've marked it there. Let's see if it's increased at all. All right. I don't know if you guys can see that, but we've actually increased significantly. That was just about 15 minutes. So we've risen in temperature significantly as well. Actually, it's so high that it's in my little thermal cap here, and we can't really see what the temperature is, but it's risen well above 20 degrees, and it was at about 5. So you can see it's risen, maybe half an inch or so in the amount of time that I've been talking to you guys. So you can really see that thermal expansion is a real thing that happens with water. It's just one of those really interesting properties that it has. And I love to teach about this stuff. So cool. This blew my mind the first time I learned this stuff. I just think it's amazing. All right, I'm going to shut off my lights here.
Beautiful. We have a seahorse question.
Oh, excellent.
So Lexi wants to know if seahorses live in groups or do they live alone?
Lexi, so wonderful to hear from you again. And that's a great question. A lot of animals in the ocean run solo. They're lone wolves, but not seahorses. They actually will live in mated pairs for pretty much their entire life. So you can see the ones that we have here, they like to hang out with each other. They're usually near each other. And these seahorses here, one thing I forgot to mention, we actually breed them. They've been reproducing and laying eggs, or not laying eggs, but hatching eggs. And we're going to hopefully be releasing these guys into the bay as we learn how to breed them. And that brings another really fun point here. Seahorses, actually, the males are the ones that carry the eggs. They can carry up to about 200 eggs at a time and give birth to about 200 individuals. When they're born, they're nearly microscopic and planktonic, and they float around in the water column eating microscopic crustaceans until they can get big enough to actually hold on to things. Now, in the wild, only maybe about 0.5% of seahorses make it into adulthood. That's about 1 in 200. We're hoping here that by breeding some and releasing them, we can increase their numbers. There's other great things that Save the Bay has done to help seahorses as well. One thing we used to do a lot of was transplant eelgrasses. So in order to try and help the eelgrass plants migrate to where they need to be to deal with climate change, we used to transplant them into new habitat zones to create larger beds for these guys to live in. Other great things to do are to make sure not to walk through eelgrass beds because it destroys them. Make sure if you're fishing not to drag equipment through because that could really harm them as well. And absolutely, it is illegal to remove any seahorses from the wild. You want to leave them out there to live and do their thing. The only reason we have them is because we want to teach about them, and we also want to try and breed them and release them. Now, seahorses are really amazing. You can see those fins flapping around, and like we said before, not great swimmers. And these guys, believe it or not, they're voracious predators. They eat live things, they hunt, and they feast. It's amazing. Now, these guys, they actually eat one of the fastest animals on the planet for its size. And that animal's called a copepod. It's a little crustacean, kind of like a shrimp. It's really small. And they can move incredibly fast. And you might think, well, how does a seahorse catch a copepod? It's not fast at all. It has some unique adaptations to do this. It's just mind-blowing stuff. So a seahorse has a really unique body shape. If you look at the shape of their body, it's actually extremely hydrodynamic, meaning it can move through the water very easily without creating any ripple effect. And a copepod senses mostly through vibrations. If it feels vibrations in the water from maybe a larger fish or a predator, it swims away. But a seahorse can move so stealthily and so slowly, it could sneak right up on these copepods, and then it has its snout, which is kind of like a little straw, except for extremely powerful, and it'll actually suck up that little copepod really quick. It creates a negative vacuum and sucks it up really, really fast, which is just an amazing thing to watch. Sometimes here at the aquarium when they're eating, we can actually hear the sound of that vacuum going off, which is really amazing. Now, if folks are ready, I am going to feed them and we can watch it, which I think is just a really fun thing. Now, we don't have any copepods for these guys today, but we have something really similar. It's just a mixture of a couple different kinds of shrimp, brine shrimp and mysis shrimp. So why don't we keep taking a look at these guys, and I'm going to start squirting some shrimp in here, and we're going to see if anyone's hungry. Oh, I think they're hungry. Look at these guys coming right up to us. Wow, they're all coming out. Look at that. What a good breakfast by the bay. Who's hungry? Now, while you guys are watching them feed, I want you to try and observe and think of any good science questions you can come up with, because I'd love to try and answer some of those.
And if we're quiet here for just a minute, we can actually hear those powerful beaks at play, or mouths. Beautiful. So I know earlier Adam mentioned the cousin of the seahorse, and you can see that guy right here. This is our northern pipefish.
Watching these guys feed is one of my favorite things to do. It's very relaxing. Now, one thing we could do right now while we're looking at them, we can actually tell the difference between males and females. So this one right here, that's a female. You can tell because her belly kind of slopes in and then cuts down to her tail. She does not have a pouch at all. The males carry the eggs in a pouch. So right here you can see, I don't know if you can see that, maybe if he turns we'll be able to see it, but that one's a male and he's got a big old pouch right there. Yeah, right there. You can see that big old pouch. It's kind of puffed out. This guy's a male too. We'll see if he shows his pouch at all too. But that's where they carry, yeah, you could really see that. That's where they carry those up to 200 eggs. And when they're about to give birth, kind of just like humans, that pouch is really, really swollen, and you can tell that they're almost ready to burst. It's a really amazing thing.
Beautiful. So Terry wants to know what the height and weight of seahorses are.
Seahorses are really amazing. The smallest seahorse on the planet is nearly microscopic, coming in at just a couple millimeters, really, really small. Those ones don't live in Rhode Island. The largest on the planet is closer to about 1.5 feet long. These guys are actually one of the larger species of seahorse on the planet. They're going to get to be about 8 inches long and weigh no more than just a couple ounces. And to be honest with you, I'm not even sure exactly how much they weigh. I would have to weigh one. I've never weighed one.
Yeah. And then Janine wants to know, what does it mean when we find seahorses in our bay?
That's a great question, Janine. Thank you. So when we find seahorses in the bay, it's a sign that you're in a pretty healthy spot. They require relatively good water chemistry in the water, so low pollutants and things like that. And they also need the habitat to be pretty undisturbed. Just like any grasses on land or in the water, if they're disturbed, they're not going to grow well, meaning if things are running into them, walking on them, tearing them up, stuff like that, the grasses aren't going to grow. And without the grasses, the seahorses aren't really going to live there. So finding them means you're probably in a healthy eelgrass bed for many different reasons.
Beautiful. And then one last question. We want to know why these seahorses are different colors.
It's really amazing. Seahorses can have different colors, at least the northern lion seahorse, depending on where they're living in the bay. If the eelgrass bed they're living in has a lot of dark coloration, so maybe really dense eelgrass, other species of seaweed growing there that are really dark, they're going to have a darker color. But if they're living in an area that has lighter color seaweed, a lot of times you're going to get a lighter colored seahorse. And even here at the aquarium, when one comes in, a lot of times they will literally change their color to match the coloration of the plants and the lighting in our aquarium here. Just an amazing adaptation. All right, guys, well, that was really fun. Thank you so much for joining us for another episode of Breakfast by the Bay. I want to remind you guys that if you enjoy this and you want to support our hard work keeping these animals alive, we'd love to have you guys donate if you're interested. There should be a little button underneath this that you can press if you like. Feel free to share this with all your friends, too. We want everyone to see it. Thank you so much, and we'll be back tomorrow at 10 a.m.